So an exponential growth and an exponential decay are going to show either an increase or a decrease. So exponential growth has two different graphs that would show an increase. So here in the first one, it's going to start low and it ends high, but from the left side to the right side, if I connect them, I get a positive sloping line. If I look at the graph below, this is also an exponential growth, even though it may not appear to be, but from the left side to the right side, if I connect them, it is increasing as well. It does not look like an exponential growth graph, but it is still increasing from the left to the right. Now the exponential decay from left to right is going to be a negative sloping line. So it's going to look almost like an L shape. If I look at the second graph, it's going to also be decreasing from left to right, and it's going to be pointing downward. So this one is a little more obvious that it would be a decay, but it is backwards from the previous graph. So here in our four examples, what we want to do is graph each equation to determine if it is an exponential growth or an exponential decay. So I'm going to take my number 1, y equals 5 times 2 to the exponent of x, and I'm going to put that in the calculator. So in my equation line, I have 5, and then in parentheses, 2 to the exponent of x. I'm going to hit enter, and I can see the graph, and it is increasing from left to right, so this is going to be an exponential growth graph. In number 2, I have y equals 3 times 1/2 to the exponent of x. So I'm going to go ahead into the calculator and graph this one the same way. So here I typed in 3 times 1/2 to my exponent of x. I hit enter, and now I have my graph, and it is decreasing from left to right. So this will be a decay. In number 3, I'm going to graph negative 2 times 4 to the exponent of x. Here I graphed negative 2 times 4 to the exponent of x, and it is decreasing from left to right. If I would connect that left side to the right side, I would see a negative sloping line, so this is a decay. For my last graph, I have negative 2 times 1/3 to the exponent of x. So I'm going to graph this one in the calculator to finish up our example. Here I graphed our function of negative 2 times 1/3 to the exponent of x, and it is going to be a growth graph. It is increasing from the left to the right.